Welcome back. Today, we're diving into episode 10 of our explainer series on U.S. patent number 12.664142. We've spent a lot of time on the theory throughout this series, but right now, we're bringing it into the real world. We're going to look at a concrete application case study straight from the patent, the Communication Appliance. We're going to see exactly how this event-driven database uses active routing nodes to trigger, log, and manage incoming events, stuff like your everyday SMS messages and emails. Let's get right to it. To see how this whole system ticks, here's our roadmap for today. We'll start with an appliance architecture overview, then look at routing incoming communications, dive into event handler nodes, see how we go about growing the tree database, and finally wrap up with triggering application logic. Basically, we're tracking the lifecycle of an event from the macro network edge all the way down to the micro leaf nodes. All right, Section 1, Appliance Architecture Overview. Our journey starts right at the edge of the network. This is where the communication appliance maintains an addressable presence. Think of it like a registered phone number sitting on a network server, just waiting for an external spark or stimulus. Now, this brings up a really fascinating question. How does a hierarchical database physically answer a phone call or route a text message? I mean, when we think of databases, we usually picture these passive, sleepy rows of storage, right? But here, the database itself is the application. We aren't just running static queries. We're relying on an event-driven setup where the database actively executes the network responses. And this brilliantly shows off the flexibility of the whole architecture. The environment can actually juggle multiple active trees all at the exact same time. Take a look at tree 1. This one is totally user-centric. It organizes and pulls all of user 1's emails and phone calls into a single dedicated hierarchy. But concurrently, you've got tree 2, which is address-centric. It might just be listening for any SMS or fax sent to one specific phone number, completely regardless of who the user is. It perfectly separates the logic and lets you build a highly customized communication flow. Moving right along to Section 2, Routing Incoming Communications. Let's zoom in a bit and actually map out the flow of an incoming text message as it hits the appliance and hunts for its destination. Following the exact steps outlined in the patent, you can see how an event moves. Step 1, the event is received at the edge device, like a Twilio server. Step 2, it cascades through listener modules and branches out at routing nodes based on the phone number or address. Step 3, once it finds the right tree, it routes to a highly specific event handler based on the type of communication. Is it an email, a voice call, an SMS? And finally, Step 4, it lands exactly at the right handler to be processed. The database is literally acting as a switchboard here. Section 3, Event Handler Nodes. Okay, so once all that routing is done, the event arrives here. This is where the system really rolls up its sleeves and gets to work. Now here's the absolutely crucial takeaway. These event handler nodes, they aren't just holding data like your traditional old-school database row. They are alive. They're active. They contain executable script modules that use an interpreter to process the raw data from an SMS or an email, format it, and literally construct brand new pieces of the database on the fly. Which leads us perfectly into Section 4, Growing the Tree Database. Let's look at the next phase and see how this system physically builds out the database in real time. When that event handler kicks into gear, it follows a very specific sequence. First up, it formats the incoming data into JSON. Then, the parent handler assigns a brand new namespace address. The patent gives a great example of this, using a format like parentAddress.sequenceIdentifier. So, if it's the third phone call to come in, it gets tagged sequentially with a 3. After that, it executes a kernel function to physically instantiate a new child node. And finally, it writes the JSON data directly into this new live runtime object. The parent node is actively growing the tree, securely logging that message data straight into the hierarchy. And the patent makes a pretty bold claim about this. It states that a tree database using this technology can grow without bound, limited only by the available hardware resources. Think about why that is such a game changer for a communication appliance. This event-driven expansion creates a built-in, limitless audit trail of every single communication that hits the system. Every text, every call, they automatically become a permanent, sequentially ordered node right there in the tree.
All right, Section 5, Triggering Application Logic. Because, let's be honest, logging the data is really only half the battle here. The tree now has to actually execute application-specific logic in response to that logged event.
What's super fascinating about this is how the patent anchors its event-driven functions back to a very established framework, the Event Condition Action or ECA paradigm. This acts as a modularized rule base. The event is the incoming SMS. The condition is whatever logical test the script decides to run, like, say, checking to make sure the user actually has an active account. And the action is the final execution step. This hierarchical database seamlessly blends that entire ECA rule structure directly into its nodes. You can see this in action if you look back at the patent's architecture. Depending on the handler, the node triggers dedicated logic scripts. Node 931 invokes call logic. Node 933 invokes email logic. Node 937 invokes SMS logic. These scripts evaluate the conditions and perform that final action. Maybe that's calculating billing minutes, pulling up a user profile, or just returning key value pairs back to the edge device to acknowledge that an SMS was received. The big takeaway? The database isn't just storing the text message, it's evaluating it and firing off the appropriate automated response.
So, this brings us to a really powerful closing thought. If active nodes inside a hierarchical database can seamlessly intercept, log, and trigger actions for global telecom events, literally operating an entire communication appliance from within the database structure itself, what other complex systems could this event-driven architecture revolutionize next? It really makes you wonder how this seamless blend of data storage and active execution is going to shape the future of real-time application development. Thanks for joining me for this explainer today, and I absolutely can't wait to explore more of this incredible patent with you next time.